Okay, ladies and gentlemen, thank you for the opportunity to bother you with some more or less informed guesses about the future in the Arctic. Let's see. Here we are. I'm from Marintech. It's an independent, not-for-profit research institute in Norway, located in Trondheim, north of here. We have offices in Bergen and Oslo, as well as subsidiaries in Houston and Rio de Janeiro. Our main activity, or most of our income, comes from the oil and gas industry. I had a small check a couple of weeks ago, and I think in 2012 we had a turnover on Arctic research on between half and 1 million euros. However, Arctic research has been picked up as one of the three main areas of interest for Marintech, because we expect tremendous growth in this area. And I'll try to give you some background why we think that is the case. Marintech is also part of the SINTEF group, as was said. That's about 2,100 employees. It's the largest independent, not-for-profit again, research institute in Scandinavia. And we cover basically all kinds of technical research and also some additional stuff. And our activities in Marintech is also leaning very heavily on SINTEF. So it's a bit wider than just our area. Marintech is also the kind of the caretakers of the big national laboratories on hydrodynamics and offshore operations in Norway. So we have a big facility in Trondheim with a lot of laboratories. So that's Marintech. No, Arctic. The three most important incomes, export incomes from Norway, is in order. It's oil and gas, it's fisheries and aquaculture, and it's maritime technology. It's quite natural, because as you see from the map, our sea area is about 6 times larger than our land area, and it's not a small country, although we have bigger cousins around the Arctic frontier. And large part of our ocean areas is in the Arctic. And as I said, we believe that a lot of the new development, kind of the technical frontier, will be in the Arctic in years to come. This also puts a lot of responsibilities on Norway. The Norwegian waters are maybe the most heavily trafficked in the Arctic area altogether, if you look at the total ship movements. And we have responsibility for search and rescue, we have a responsibility for maritime safety information, weather forecasts, and things like that. So in addition to all the commercial interests, we also have a management responsibility in this area, which is also driving a lot of the research. So if you look at the market drivers, these are not very systematic, but these are the ones we see will have the most impact. It's first and foremost oil and gas. There's huge resources of hydrocarbons already detected in the Arctic areas, and more will be found. That's quite certain. It's relatively difficult to get to these areas, so development currently is a bit slow due to prices, particularly on gas. But this is also going to change. We expect a quite high increase in demand for natural gas, particularly liquid natural gas, for instance, for ship fuels. And this is what we think will be the major driver in terms of new technology and investments in research. We have seen this in the North Sea before, and this is what we expect also in the Arctic. We should also not forget that there are probably vast natural resources in form of minerals in Greenland, in Russia. And you have the problem, for instance, with the rare earth metals, and it's not unlikely that we can find sources of that in these areas also. We already have some mining on the north part of Greenland. which is expected to increase over the years. Shipping, the ice is disappearing. The bar graph shows ship movements through the Northern Sea route in the years from 2009 to 2012. And although there is not a big traffic yet, but there's a tremendous increase. And this is also most likely going to increase. Currently we have some problems with the fee structure going through this area. But the Russians are working on this, and this will dramatically shorten the transport distance from Europe to Asia and the West USA. Our previous speaker talked about the fisheries. We see the fish moving north. There's already big fisheries going on in the Arctic areas, and this will probably increase. So this is also going to be an important driver for developments in the Arctic. Interestingly enough, tourism is also expected to increase and will be a factor. I checked the statistics for Longyearbyen expected calls in 2013, and there are 110 cruise ships calling Longyearbyen this year in the summer season. 47 different ships. 4 of these ships carry more than 2,000 passengers. The largest can carry up to 3,000 passengers. And there's also cruise ships passing through the east coast of Greenland, which I'll come back to it, but there are some challenges here for search and rescue and evacuation. One response to our responsibilities in this area is that the Norwegian Coastal Administration, together with some other companies, launched their own AIS satellite. So they are now able to pick up AIS signals from passing ships in the Arctic region. It's a polar orbit, particularly targeted for this area. And this plot shows one dot is one ship day. The dark blue is in the Norwegian zones, the others are in foreign waters. And it gives you an impression of the density of ship movements in this area. There's already a lot of ship traffic, and this will increase. So, these are what we think are the main market drivers. There are also others, but I think these are the main. So what are the technological challenges we see? Again, the focus is from marine tech, so it may not cover all the issues, particularly environmental and exploration, but let's have a look anyway. Operation in ice is not so important for us in Norway because most of the activity is actually driven by the reduced amount of ice. And Norwegian waters are up to Svalbard mostly ice-free, except for drifting, some drifting ice. But still, particularly when we go further north, and if we want to use the transpolar route, which may be opened in, say, 20 or 30 years, operation in ice will be an issue. However, more important is icing and low temperatures. We have problems with ice accumulating on the superstructure of ships, on the equipment, antennas, for instance, and we need new technology and new systems to try to keep this under control. A serious problem is visibility in these areas. There's a lot of fog. In the wintertime, we have total darkness, and this have quite some challenges for the operators of the ships, the watchkeepers on the ships. Again, we probably need new sensors here, particularly low-light systems and radars. A major problem is lack of data, missing forecasts. We have a problem in the Arctic with this rapidly developing low pressure systems. And the forecast systems, there's a lack of measurement stations, there's a lack of models and so on. So we really don't have the quality on the weather forecasts that we need for extended operation in these areas. A big problem that we are working with currently at MarineTech is communication systems. Most ocean communication systems are based on geostationary satellites. And these satellites, they disappear below the horizon when you get up to about 80 degrees. And you also get trouble with this because when you have a low inclination, you will have problems with disturbances in the signal. So up to 75, we have reasonably good geostationary coverage, but above that, which is the white ring, we have to rely on one satellite system alone, basically, which is Iridium, 128 kilobit at most, and not always optimal quality. So this is actually one of the major showstoppers currently for extending advanced operations beyond 75 degrees. One of the possibilities we are looking into is highly elliptical orbit satellite systems. It's basically a kind of pseudo geostationary system. Looks more or less like the traditional, but with the satellites above the pole. Unfortunately, this costs several million euros to launch, and there's not currently an economic model to support this. So we are thinking about how to manage this feat without just looking at the commercial operations. Other possibilities are combinations of unmanned aerial vehicles, mesh networks, ad hoc networks, and so on. So again, this is a big area for research, for us and for others. The distances, as I said, was huge. Let's see if this works. There are no ports on the east side of Greenland. We have Iceland, have good ports. We have Svalbard with ports, and nothing in between here. Then you have to go to Norway. So base to operational distance in these areas can amount to 400 to 600 nautical miles. And this is a big challenge. If you go farther north, again, up here, the electronic charts are either not existing or are extremely bad quality. So navigating in these waters is difficult. The positioning systems work fairly well, but still you don't get very high lateral or vertical resolution on this, on GPS and GLONASS and the other systems. And there's also a lack of correction system, so you don't have the accuracy that you have in the North Sea. Logistics, due to the distance from the bases to the operational areas for all kinds of operation, oil and gas in particular, is a big problem. You have sailing times of 2 to 3 days in worst case, and you can't move crew by helicopters. You have to use boat, and this is quite expensive. There's no coverage for the international global distress and safety system above about 80 degrees or 70 to 80 degrees. Nothing at all. There's actually no approved emergency communication system in these areas. Distance for search and rescue. Again, Norway has responsibilities for search and rescue in these areas. We are talking about several days sailing time. Maybe out of reach of helicopters. Cruise ships with 3,000 passengers, if something happens, how are you going to evacuate it? It's basically not possible. So we also need to look at the safety systems on board these ships. So, if I personally was to pick one technology that I think may be a game changer in these areas, will be of very high importance in future developments, I would point to autonomous systems. Long-distance airplanes can be used for search and rescue. It can be used for communication, setting up multi-hop communication systems. It's an obvious choice for subsea operations in these areas where you have difficulties getting crew back and forth, and also for all kinds of measurements, under ice, over ice, in the air, meteorological, and so on. So this is really one of the technologies I think will have a great impact in the years to come in the Arctic regions. It's really one of the regions that has some good and real challenges for autonomous systems. This has also been picked up by Norwegian research authorities. So the university in Trondheim recently got approved a center, Norwegian Center of Excellence in research for autonomous systems and environmentally friendly energy systems. So they have a budget of about 600 million Norwegian kroner over 10 years. That's a bit less than 100 million euros. And have huge plans for PhD developments, research projects, and so on and so forth. So this will be a big actor in autonomous research in the years to come. Likewise, at Marintech, we are now in the process of releasing about €500 million for building new laboratories. And one of the pillars for these new laboratories is Arctic research and also autonomy. So with some good luck and help from all our politicians, we hope that we can start this process in, say, 2015-16. So you are welcome to Trondheim to have a look at these laboratories when they are finished. Don't hold your breath, but it will come. And that was it. Thank you.